All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is heat calculations. You are going to need a calculator for this one, so if you don't have one handy, go ahead and pause the video and we'll get started. The formula that we're going to be using today is Q is equal to MC delta T. So let's define each one of these variables. Q is the amount of heat being transferred into or out of a substance. So for example, a body of water, for example. So the Q is the amount of energy in joules being transferred into or out of some substance. M is the mass of that substance measured in grams. C is a variable called specific heat. We'll talk more about this later, but it is unique to each substance. So for example, the specific heat of water would be different than the specific heat of, say, gold or silver. Delta T is the change in temperature in degrees Celsius that we witness in this heat transfer. So let's start with number one. Here's what it says. Number one says, how many joules of heat energy are required to raise the temperature of 550 grams of water from 12 to 18 degrees Celsius? And they tell me the specific heat of water is 4.184, and these are the units, joules per gram per degree Celsius. 4.184 joules per gram per degree Celsius. So here's how we're going to proceed. We're going to start with the main formula. Q is equal to MC delta T. Now they're asking me for the amount of heat energy required, and they're saying they would like me to present that answer in joules. So here's what I'm going to do. I'm going to solve for Q. It's already by itself. So Q is equal to the mass of the water. In this case, it's 550 grams of water times its specific heat. That's the C. And it's 4.184 joules per gram per degree Celsius. It's nice to be able to remember that because water is such a common substance, but I'll give it to you on quizzes and exams. So if you don't absolutely have it memorized, don't worry about it. 4.184 joules per gram per degree Celsius. And then we're going to multiply that by the change in temperature. Now let's take a look at the change in temperature. We went from 12 to 18 degrees. We heated it up, in other words, by 6 degrees. So 18.0 minus 12 degrees is going to give us that 6 degree temperature change. So when we multiply all three together, 550 times 4.184 times 18 minus 12, we get this number, 13.807.2, 13,807.2, and remember, that's in joules, right? We want our answer in joules, and that's what we've got. But let's clean it up just a little bit with significant digits. We want only, let's see, 2 significant digits. So we'll use this 8 to push this 3 up, and we get 14,000 joules. That's our first answer. We're done with number 1. Let's go to number 2. Here's what it says. Number 2 says, how many kilojoules, abbreviated KJ, of heat energy are necessary to raise the temperature of 350 milliliters of water from 1 to 5 degrees Celsius? Again, the specific heat of water is given as 4.184 joules per gram per degree Celsius. So here we go. We're going to use our formula. Q is equal to MC delta T, just like that. And we're going to start plugging in. But let's notice something about water, and that is this. They're giving me the volume of water as 350 milliliters. But here's what you need to remember. Water has a volume of 1 milliliter for a gram of water. So 1 gram of water, that's a mass, has a volume of 1 milliliter of water. So they're interchangeable. 350 milliliters can be written as 350 grams. So I'm going to write it as grams since that's what I need for the formula. 350 grams instead of 350 milliliters times the specific heat of water. In this case, it's 4.184 joules per gram per degree Celsius. And what was the temperature change? We went from 1 to 5 degrees Celsius. It was heated by 4 degrees Celsius. We'll denote that by 5.0 degrees Celsius minus 1.0 degrees Celsius. When we multiply across, here's what we get. 5,857.6 joules. Let's clean that up. 5,900 joules. But we've been asked for our answer to be in kilojoules, right? How do we convert joules into kilojoules? Here's what we're going to do. We're going to divide by 1,000 or multiply by 1 over 1,000. Notice joules and joules are going to cancel away. and we're going to be left with this number, 5.9 kilojoules of heat. So that's the amount of heat necessary to go for this amount of water from 1 degree to 5 degrees Celsius. We're done with number 2. Let's go to number 3. Number 3 says the specific heat of iron is 0.4494 joules per gram per degree Celsius. That's not the same number that we saw for water, but we wouldn't expect to be. It's not the same thing. How much heat energy, and they want the answer in kilojoules, is transferred when 24.7 kilogram iron ingot is cooled from 880 degrees Celsius to 300 degrees Celsius, 13 degrees Celsius. So quite a difference in temperature here, but we're going to use the same formula. Q, that's the amount of heat energy, is equal to M, that's mass, that's specific heat, times the change in temperature. Let's make sure we get the right numbers here. 24.7 kilograms is 24,700 grams. I multiplied it by 1,000. I have to remember to keep it in grams. Times the specific heat of not water, but this particular metal. All right, this particular iron ingot. It's 0.4494 joules per gram per degree Celsius. The change in temperature was, we went from 880 to 13, so 880 minus 13, and we're going to multiply all that across. When we do that, we get this tremendous number here, 9623856.06. I'm going to divide that by 1,000 because, look, they're asking me again for the answer in kilojoules. So when I divide by 1,000, I get 9,623.86. I'm going to polish that up just a little bit. Remember, I need, let's see, 3 significant digits. So I'm going to make that 962. Does the 3 push the 2 up? No, it's not big enough. 9,620 kilojoules is my final answer, and I'm going to go on to number 4. Here we go. Number 4, I hope these are going okay for you. Let's take a look at number 4. It says, find the specific heat. We're looking for a different variable this time. We're looking for that CP, right? That C sub P is what we're trying to find now of an unknown metal. It's not the same metal ingot we saw in the previous problem. This is a different one. So we expect to see a different number. With an initial temperature of 16 degrees, when 3,500 joules are applied to a 40-gram sample, and a final temperature of 81 degrees. So we're going from 16 to 81. The amount of heat that's applied is 3,500 joules. Remember, that is in joules. And it's a 40-gram sample. So let's get to work. First thing we need to do is a little algebra. We have Q is equal to MC delta T. Get that CP alone by itself. I've colored it in a different color so you can see that's the one I'm looking for. To do that, I'm going to divide both sides by M delta T. So I'm going to write it over here. C sub P, that's the specific heat I'm looking for, is equal to the amount of heat transferred, that's Q, divided by the mass divided by the change in temperature. Let's start plugging in here. How much heat energy is applied? 3,500. Make sure it's in joules. It is. So 3,500 joules divided by the mass. Well, it's 40 grams, 40.0 grams, I should say. Don't lose that last significant digit. So 40.0 grams divided by the change in temperature. We went from, let's see, 16 degrees Celsius to 81. So the difference is 81 minus 16. When I multiply, actually there's nothing to multiply on top. It's just 3,500 on top. But I'll divide by 40 and divide by the difference between 81.0 and 16.0. On my calculator, here's what I get. I get 1.3. Let's get the units right. It's joules per gram per degree Celsius. Those are the units for specific heat. So I'll report that as my final answer. Final answer, 1.3 joules per gram per degree Celsius for this unknown metal. I'm done with number 4. Let's move on. Number 5. Find the mass of a piece of copper. They're identifying the metal this time. When 8,000.0 joules of heat are applied, causing a 45 degrees Celsius increase in the temperature of the copper. Notice they're not telling me this time what the initial temperature and the final temperature is. They just say it's a 45 degrees Celsius increase. That's all we need to know. So let's use our formula. We have Q is equal to M times C sub P, that's specific heat, times delta T. We're going after M. I've colored it in blue to indicate that that's the one we're looking for. So we're going to say M is equal to, I'm going to divide everything by C sub P delta T. So I get that's equal to Q over C delta P, sub P delta T. Let's plug in. So M is equal to 8,000. Make sure it's in joules, right? You don't want to put kilojoules there. It's got to be in joules. And it is 8,000 joules divided by the specific heat they're telling me is this number, 0.38452 joules per gram per degree Celsius. It's right there. And then divided by that temperature change, that change in temperature. I don't need to know the original and final temperature. All I really need to know is the difference in temperature. It's 45 degrees Celsius. When I say 8,000 divided by 0.38452 divided by 45, here's the number I get on my calculator, 462.3 grams. Let's tidy up a bit. I only want two significant digits. The 2 cannot kick the 6 up. I'm going to call my final answer 460 grams, and we'll go to the last one. Number 6. Here we go. How much heat energy in kilojoules is lost when a 640 gram piece of copper cools this time from 375 degrees Celsius to only 26 degrees Celsius? They give me the specific heat of copper, 0.38452 joules per gram per degree Celsius. So let's use our formula. We're looking for Q, the amount of heat energy. They want it in kilojoules though, don't forget. We want this answer in kilojoules. So we got Q is equal to the mass times specific heat times delta T. That's the basic formula there. That's equal to 640 grams. They tell me it's a 640 gram piece of copper times the specific heat for copper. It has to be for copper because that's what the substance we're dealing with. 0.38452 joules per gram per degree Celsius. That goes right here. Times the change in temperature. Remember, I'm going from 375 to 26 degrees Celsius. We'll take the difference in degrees Celsius. When I multiply all that across, here's the number I get. 85,886 joules is equal to, let's get the right number of significant digits. I want only 2. So the 8 will kick this 5 up. I'm going to have 86,000 joules. I'm being asked for my answer in kilojoules. I'm going to divide that number, remember, by 1,000. That gives me 86 kilojoules. That's my final answer. That'll do it for this worksheet. I'll see you on the next one. Thanks. Bye-bye.